Good afternoon, students. So today we are going to discuss about the topic that is electric potential and capacitance. Okay. So before going to this or before going to discuss this topic, let us see that what is charge. What is charge first? Charge is nothing but it is an intrinsic property of a body because of which an electrostatic force is said to be take place. That means here charge is responsible for the electrostatic force between the two objects. For example, negative charge means suppose I have taken two electrons, they two will get repel each other. If I take one electron and one proton, they will get attract. Why? Because of the charge. So that means if the body is or if the object is having a charge, then a force of attraction or the force of repulsion takes place. So this intrinsic property because of which this electrostatic force is said to be take place, this intrinsic property is called electric charge. This is similar to that of the we have learned in our first year, that is gravitational chapter. There, mass is an intrinsic property which is responsible for the force of attraction between the any two body. We know that, right? Similarly, there, mass is an intrinsic property. Here also, similarly, charge is an intrinsic property because of which force of repulsion or force of attraction takes place between the two charged bodies. Here, right now. Now, here we are going to discuss about the electric potential and capacitance. So first, let us see what is electric potential is. Electric potential. What is electric potential actually? What is electric potential? As we know that, suppose say this is a positive charge I have taken. As we know that this is a positive charge means always electric field will be radially outward. We know this very well. So electric field will be always radially outward. Now here I wish to calculate the electric potential at a point P, which is at a distance say that is R of this charge. This charge is having potential at this point. How much? That is called electric potential. So at this point, how much electric potential is there of this charge? That we have to first I will define it, and after defining that, I will derive the expression for that also. Let us define how it is. Here, to define the electric potential at this point of this charge, for this we have to from infinity, we have to bring a unit positive test charge. Q naught plus positive Q naught. This is nothing but this is called unit positive test charge, whose magnitude is of 1 unit, and it does not affect any other charge when we place beside it. Means what? Its force of experience is very less. Means it does not exert much force on any other charge. Okay, so this is called unit positive smaller charge I have taken here. From where? From infinity to this point I am bringing the unit positive test charge from infinity to the point P. So for this I have to bring, that means for this I have to do some work. So this work will be stored in the form of electric potential. So this work itself is called electric potential. Let us see how. Suppose say from infinity this Q naught I am bringing against this electric field. As we know that electric field is always radially outward. That means electric field of this charge will be in this direction. Since this is positive, that is also positive. Whenever I am bringing, definitely this will be repelling it. So against this electric field, I have to bring that charge. So how long I have to bring this? From infinity to this point. So for this, whatever the work I am doing, this work is said to be an electric potential. For example, I want its potential at this point, suppose. So I have to bring from infinity to this point. If I want its potential at this point, then I have to bring the charge from infinity to this point. Getting what I'm saying? So wherever you want its potential up to there, up to that point, you have to bring a unit positive test charge from infinity to this point. Getting what I'm saying is, so how to define this one again? Once again, I define this one. This electric potential at this point. The amount of work done in bringing a unit positive test charge from infinity to the point at which we wish to calculate its potential energy. This amount of work done is called its potential energy. Clear what I'm saying? So for this, a formula we can write. V means what? Nothing but this is electric potential. We will represent with letter V. So work by charge. V is equal to W by charge. Work done per unit charge. Getting what I'm saying is, so this is only I have told in the form of definition. The amount of work done in bringing a unit positive test charge from infinity to the point against the electric field. Against the electric field, this work done will be stored in the form of electric potential. And this is given by V is equal to W by Q naught. What is its unit? And what is how it is? Its unit is, or its SI unit is, what is the unit of W? Work, joule, joule. This one, coulomb. Joule per coulomb is the SI unit of this electric potential. Or simply we call it as also we call it as volt. This is capital V. V means what? Volt. Clear what I'm saying is? So हम joule per coulomb भी बोल सकते हैं, नहीं तो इसे हम volt भी बोल सकते हैं. So this is nothing but the SI unit of this electric potential. यानी इसका potential यहाँ कितना है? How many volt is there? So this much volt बोलकर हम बता सकते हैं. 10 volt, 5 volt, 3 volt ऐसा. Getting what I'm saying? So this is called its unit. Next, it is a scalar quantity. It is a scalar quantity. It is a scalar quantity होता है बड़ा. क्या होता है ये? Scalar quantity. Clear what I'm saying? So it is a scalar quantity. It is not a vector. It won't have any direction. Don't think that this is the direction. This is electric field direction. I am finding at this point potential is how much value, magnitude it will tell. It won't tell any direction. Clear? Electric field is having a direction, but electric potential won't have any direction. Clear? Fine. Now, from this, now I will define electric potential difference. Electric potential difference also we can say. See, next here is electric potential difference. This I will represent it with letter dV. dV means difference in voltage. Okay, how to define this? See carefully. Suppose say the same charge I am bringing I am grabbing this one. Okay. The same charge I am bringing from one point to another point against the electric field. Electric field is in this direction. Suppose say I am bringing a charge that is Q naught from here to here. Suppose say from A to B. So in this way I am bringing against the electric field. Electric field is like this, but I am bringing the charge from A to B in this direction. So here the potential I can say that, let us say that is VA is the potential at a point A. Let us say at point B, VB is the electric potential at a point B. Therefore, what is the difference in potential? VB minus VA. Keep in mind that this will be greater than that. So the potential when you reaches nearer to the charge, the potential is increasing. I will derive in the derivation you will come to know. Okay. So here the potential at VB is greater than VA. That means the potential difference is given by VB minus VA. This is called simply potential difference. That is, I will tell it as the dV. Change in potential is nothing but VB minus VA. This potential minus that potential. The change in potential is equals to, again, same formula. Work done per unit positive test charge. Okay. So how much, what is the potential difference means? From here to here, how much work you are doing? That work is this one. Previously I told V is equal to W by Q naught. That is from infinity to this point. So from where to where you are bringing, that whatever the total work you are doing, that work is given by this one. Clear? Potential difference means this point to this much. This much of work is done. Clear what I'm saying is? So this is called electric potential difference. How to define this? As I told you now, the unit of electric potential is what? Volt I told. So when you will get 1 volt, when I can say this difference as a 1 volt, कब हम इसको 1 volt बोलकर बोल सकते हैं? इसको हम अगर 1 volt अगर बोला, if I say this as a 1 volt, then definitely this should be what? 1 joule होना चाहिए, and this should be a 1 coulomb होना चाहिए. So how to define this 1 volt means Again, I will define. How to define this 1 volt means the 1 volt is the electric potential is said to be a 1 volt if the work done is of 1 joule in bringing 1 coulomb of charge from one point to another point. This work is said to be a 1 volt. Again, I repeat, 1 volt is nothing but, how to define this 1 volt? 1 volt is nothing but the electric potential difference is said to be 1 volt when 1 joule of work done in bringing 1 coulomb of charge from one point to another point. तो यहाँ से लेकर यहाँ तक लाने के लिए ये डिफरेंस जो है, ये यहाँ से लेकर यहाँ लाने के लिए हम 1 पोटेंशियल डिफरेंस बोलेंगे. कब? अगर इसको इधर से लेकर लाने के लिए 1 जॉल ऑफ वर्क करना पड़ता है. कितना चार्ज लेकर? 1 कूलम ऑफ चार्ज. 1 कूलम ऑफ चार्ज यहाँ से लेकर यहाँ तक मूव करना पड़ता है. उसके लिए आपको 1 जॉल ऑफ वर्क करना पड़ता है. तो ये 1 जॉल बाय 1 कूलम को हम क्या बोलेंगे? 1 volt. So 1 volt is the potential difference between these 2 points. I can say. Getting what I'm saying is, so this is how we can define the electric potential also. 1 volt. 1 volt. Clear? So 1 volt हम ऐसा define करेंगे. Clear? Right. Now let us go for the derivation of this one. Our expression for or derive an expression for derive an expression for electric potential at a point due to an isolated point charge. तो ये एक मैंने isolated point charge लिया, इसका potential कोई भी point पर कितना है derive करिए बोलकर बता रहे हैं. ठीक है, definition क्या था? V is equals to W by charge, यानी work by charge. ये हम definition से हम इसको derive करेंगे. Let us see. Let us consider that this is one charge I have taken. This is a charge I have taken. Here I wish to calculate the electric potential at a point P, which is at a distance R. Let us say this is a charge, point charge, isolated point charge, whose charge is Q. Here I wish to calculate the electric potential at a point P, which is at a distance R. So R distance पर यानी ये point पर हमको इसका potential find out करना. उसके लिए हमको क्या करना चाहिए? What I have to do? I have to do some work from where to where, from bringing a unit positive test charge from infinity to this point. So from infinity, somewhere from infinity to this point, I am bringing a unit positive test charge. I am bringing. Okay, I am bringing from infinity to this point like this. So while bringing, I am considering a small points. Suppose say I have taken a 2 points. I have taken. Say this is one is of A. Say one is of. Say that is one is of B. A or B बोलकर 2 points लिया. And while bringing this unit positive test charge from infinity, I am observing that when it is moving from A to P. Let us say this charge is moved from A to P. Of how much distance? Say this is of distance dx. Say this distance. Say this is of x is the distance. This point is at a distance. Say this is R. Okay. Getting what I'm saying is, so here from infinity to this point I am bringing a charge. So here I am doing a work in bringing a unit positive test charge from infinity to this point. So this work I have to calculate. So to calculate this much of work, first I will calculate a small work between A and B. So for this, what is required? Work is equal to force into displacement. So displacement, let us say this is dx is the small displacement. What is the force here? The force is nothing but the force between this charge and this charge when it brought here. So let us say when a charge at this point, say this is Q naught when I brought here, then the force between these two is how much? What is the formula for the force between the two charges? Force between two charges is nothing but, we know that formula, F is equals to 1 by 4 pi epsilon naught into Q1 Q2 by R square. So here Q1 means Q, here Q2 means nothing but Q naught divided by these two distances, how much between them? X square. So this is the force. Clear what I'm saying is? So this much of force is there. Therefore, the small work done in bringing a unit positive test charge, that is Q naught, from A to B is given by what is the formula for the work? Small work. So dW I am taking. dW is equal to force into displacement. Force into displacement. Yes, here force into displacement. But here one more thing we have to consider here. Force into displacement means here displacement is in this direction, but the force will be in that direction. Why? Because we know that this is positive. This positive will repel this positive in that direction. सही है ना बेटा? ये उसको ओ साइड रिपल करेगा. तो ये फोर्स ओ डायरेक्शन में, डिस्प्लेसमेंट ऐसा है, फोर्स ओ डायरेक्शन में. इनका बीच का एंगल कितना बेटा? 180 डिग्री है कि नहीं? So therefore I can write that dW is equal to force into displacement into cos of 180. We know this formula. Fs cos theta, W is equal to Fs cos theta. वर्क पावर एनर्जी इसमें वो चैप्टर में देखा ना बेटा? Fs cos theta ये वही है ना? F means displacement. Cos theta, here theta is nothing but angle between F and S. So 180. So this will become minus F into dx we are getting. So this is what we are getting. So dW is equal to minus F into dx. What is F here? F is nothing but this is the force acting. Between ये दोनों का बीच में फोर्स ये है. तो ये हम इधर सब्स्टिट्यूट करेंगे. Therefore dW is equals to minus of F means what here? 1 by 4 pi epsilon naught into Q naught by x square into, this is the force, into dx. Clear? So what is dW here? dW is nothing but it is the small work done in moving a charge from A to B. A से लेकर B तक लेके जाने के लिए उतना काम करना पड़ा. लेकिन हमको इधर पोटेंशियल होना, तो हमको कहां से कहां तक लेके जाना पड़ा चार्ज को? फ्रॉम इंफिनिटी टू ये पॉइंट तक. तो ये पॉइंट कहां है? कितना डिस्टेंस पर है चार्ज से? r डिस्टेंस पर है. इनिशियल वो कहां था? इंफिनिटी. ये पॉइंट से इंफिनिटी पर है एक चार्ज, वहां से लेकर यहां तक लेके आना पड़ रहा है ना? मतलब हमको r डिस्टेंस तक लेके आना. तो here I have to do the work done in bringing a charge from infinity to the point P, which is at a distance r. So ये छोटा वर्क है. तो हमको ये पूरा वर्क करने के लिए हमको क्या करना पड़ेगा? We have to integrate. We have to integrate. Therefore, on integrating above equation within proper limits, that is from infinity to r, we will get the total work. अगर हमको टोटल वर्क आ जाता तो इसको हम क्या करेंगे? इंटीग्रेशन ऑफ dw ये भी माइनस ऑफ इंटीग्रेशन ऑफ 1 by 4 pi epsilon naught into q naught by x square into dx. कहां से कहां तक मैं इंटीग्रेट कर रहा हूं? इंफिनिटी टू r. सो इंफिनिटी टू r, इंफिनिटी टू r. दिस आई कैन राइट सिंपली एज अ w बोलकर लिख सकते हैं. w इज इक्वल्स टू, यहां पर जो भी कांस्टेंट है वो बाहर लिख लेंगे. माइनस ऑफ q naught is constant divided by 1 by 4 pi epsilon naught. This is also constant. Therefore, integration of dx by x square. Therefore, minus q naught by 4 pi epsilon naught into integration of infinity to r. This can, if it is going up this, I can write x power minus 2 into dx. We can write. Can I write like this? So now, how this formula is? Just take it quick, make it fast. Make it fast, make it fast. This side over now. On integrating above equation within proper limits, that is from infinity to r, we will get the total work. So इसको हम अगर इंटीग्रेट करेंगे तो हमको टोटल वर्क आ जाता है. ठीक है, तो यहाँ देखो नेक्स्ट इसका कंटिन्यूएशन देखो. W is equals to minus q naught by 4 pi epsilon naught is there. Therefore, here if you can see here, carefully see here, integration of x power minus 2 dx. It is like a integration of x power n dx जैसा है. तो इसका हम लोग जनरल फॉर्मूला इधर लिख रहा हूँ. As we know that integration of x power n dx, इसका फॉर्मूला होता है x power n plus 1 by n plus 1 plus some constant. ये constant हम लोग को जरूरत नहीं है. ठीक है, तो x power n plus 1 by n plus 1. If suppose some limits are there, like suppose a and b, suppose some limits are there, then instead of this x, once we have to place the upper limit minus again lower limit. Like for example, here x means first we have to substitute here b power n plus 1 minus of, once again we have to calculate substitute a power n plus 1 whole divided by n. So upper limit minus lower limit करना है. तो ऐसे इसी का तो इसको भी करेंगे. देखो the same thing I will write. See, x to the power n dx जैसा ना. Here also it is like a x power n dx like. Okay, so for this I will write x to the power minus 2 plus 1 by minus 2 plus 1. इसका तरह मैंने लिखा है. लिमिट्स इसको लिखना. देखो इधर लिमिट ऐसा लिखना a b. Similarly for this is what? Infinity r. Therefore minus q naught by 4 pi epsilon naught into what we can write for this? X power minus 1 by this will become minus 1. So this minus will get cancelled. Therefore q naught by 4 pi epsilon naught into this is nothing but x power minus 1 means I can write 1 by x. So this we can write it as a 1 by x. Limit is from infinity to r. Therefore, q naught by 4 pi epsilon naught into. Now I have to substitute what? Upper limit once I have to substitute. That means 1 by r minus again 1 by infinity. So upper limit minus lower limit I have to substitute. As we know that 1 by infinity is 0. Therefore, what is left here? 1 by 4 pi epsilon naught into, this can be written as q naught by r. Can I write like this also? So this is nothing but this is the work done. So this is what I am getting work done. What is our requirement? हमको क्या चाहिए? इलेक्ट्रिक पोटेंशियल चाहिए, है कि नहीं? So from the definition, what is the from the definition of electric potential? Electric potential क्या बोलता है? Work per unit charge, है ना बेटा? The amount of work done in by bringing a unit positive test charge from infinity to that point. So I want a potential. Still now I have calculated work. Now I will substitute this work here, then I will get its potential at that point. So therefore, V is equals to, work means what here? 1 by 4 pi epsilon naught into q naught by r whole divided by q naught. So this q naught, both are equal, will get cancelled. What is left here finally? What is left here finally? Finally, it is left with V is equals to 1 by 4 pi epsilon naught into q by r. So this is the electric potential at that point. So as I told you previous that if you move towards the charge, the potential is increasing, I told you. So here how we can say means here see, V is here inversely proportional to r. So as the r increases, V decreases. If r is decreasing, then V will be increasing. Getting what I'm saying is, so this is how we can see. Next, this is the expression for an electric potential at a point due to a charge Q. So that is now see here. Electric potential at a point due to a positive charge plus Q, that is given by this problem. If suppose instead of positive charge, if I have taken as a negative, for example, say as I told you that initially I have taken a positive charge whose charge is Q, I told. Yes. For this, what is the electric potential at a point P at a distance r? Means this is positive charge. So that formula V is equal to 1 by 4 pi epsilon naught into Q by r. Actually, this is positive. If suppose instead of positive, if I have taken as a negative charge, suppose this is of a negative charge, negative value, then electric potential at a point P at a distance r, at this point its potential will be simple. Just we have to place here negative charge. 1 by 4 pi epsilon naught into minus Q by r. That means the value will be of a minus 1. Matlab minus 1 by 4 pi epsilon naught into Q by r. So this is the potential. If you take negative charge, the potential will be negative value. If you take a positive charge, the potential will be positive value. Getting what I'm saying is here. Well, this is simple formula. This you take positive, here this will be negative. That's all. Okay, so let us this one. Right. Now see, electric potential due to a, suppose I have taken a spherical shell. Spherical shell means electric potential due to spherical shell. So this will be some this formula is useful for the solving the problem. Problems में ये use होता है. Spherical cell का electric potential कैसा होता है? Spherical cell बोले तो suppose से मैंने ऐसा एक cell ले लिया. Suppose this is a shell. इसके ऊपर charge. Suppose this is a charge Q is there on the surface. Now there are several possibles are there. What is the electric potential at a point P, which is at a distance, say this is small r. Here radius is, say this is capital R. Here outside the point, this is outside the road. So outside में कितना electric potential है बोलो तो electric potential at this point is given by V is equal to 1 by 4 pi epsilon naught into ये surface का अंदर कितना चार्ज है वो देखना. ये surface का अंदर कितना चार्ज है बेटा ये ना Q है ना. So 1 by 4 pi epsilon naught into Q by this distance is R. So this is the electric potential outside. On the surface is how much? Means at this point I have to consider on the surface. So now here on the surface, this is outside. Outside. Next is on the surface. किसी book में on बोलते or we can say it as a just outside. कोई book में इसे just outside भी बोलते मतलब on the surface. ठीक है? तो on the surface में कितना होगा बोलो तो same formula. V on is equals to 1 by 4 pi epsilon naught into same charge Q by ये distance क्या होगा बोला? Capital R. So I can write here it as a capital R. So outside is small r is greater than capital R. But for on the surface it is small r is equals to capital R. So I am taking it as a, instead of this I am taking it as a capital R. Getting what I am saying is, now suppose I am getting inside. Inside में कहाँ कितना है? What is the electric field inside the what is the potential inside this sphere? So inside the sphere I have to consider. Suppose I have taken one sphere I have taken of small r inside. So inside बोले तो यहाँ पर r is greater than less than capital R होना पड़ेगा. यहाँ r छोटा है capital R से ये छोटा है ना. इधर ये बड़ा है इधर ये छोटा है कि नहीं inside. So inside to calculate inside एक formula आता है. What is that formula? Electric field E is equals to dV by dr बोलकर minus dV by dr बोलकर one formula. I will derive that one from the already I am telling you why we will get here. What we will get here? E is equal to minus dV by dr. Electric field inside the spherical shell we have learned in a Gauss theorem. We have learned in a Gauss theorem that inside the electric field is zero. Why inside electric field is zero? Because charge inside is zero. Because inside कोई charge है क्या? Charge नहीं. जब charge नहीं है तो electric field zero होता है. जब electric field zero हुआ तो electric field और electric potential का बीच एक relation है. क्या वो relation E is equal to minus dV by dr. So this inside बोल रहे हैं. Inside this is zero. Inside वो zero है. So the differentiation of something is zero means what will be this one? It should be a constant. We know that the differentiation of any constant is zero बोलते हैं. D by dx of x square को अगर बोले तो क्या बोलेंगे बेटा? D by dx of x square का differentiation क्या होगा? n into x to the power n minus 1 है ना बेटा? देखो ये वाला d by dx of x power 2 अगर बोला x स्क्वायर बोला तो क्या होगा ये 2 into x to the power 2 minus 1 यानी 2x होगा। जनरल फॉर्मूला क्या है बोले तो d by dx of x power n अगर बोले n into x to the power n minus 1 ये डिफरेंशिएशन होगा। सिमिलरली ये सारे वेरिएबल्स here this is the variable with respect to x, this is also varying with respect to x. So with respect to x, if I take any constant, suppose say a is the constant, the differentiation of any constant is said to be 0. Okay, so d by dx of something is 0 means what should be this one? ये should be क्या होना चाहिए? कांस्टेंट होना चाहिए, ये हम लोग को पता है। तो सिमिलरली यहाँ देखेंगे अगर e का वैल्यू 0 हुआ मतलब dv by dr का वैल्यू 0 होना चाहिए। दिस इंप्लाइज दैट v क्या होना चाहिए? कांस्टेंट होना चाहिए। क्या होना चाहिए? कांस्टेंट। दैट मींस इनसाइड द इलेक्ट्रिक पोटेंशियल इज कांस्टेंट। कांस्टेंट का मतलब इसका सरफेस पर जो पोटेंशियल है अंदर भी सेम होना चाहिए, यानी अंदर भी सेम कांस्टेंट होता है। So here I can say that V inside is nothing but same constant as that of the V on. V on में क्या होगा? ये है ना, तो inside भी सेम होगा, यानी 1 by 4 pi epsilon naught into Q by capital R. So on the surface may be 1 by 4 pi epsilon naught into Q by R. If you go anywhere inside at the center or anywhere if you take, electric potential is constant, same as that of the on the surface, but electric field is 0. Keep in mind, inside electric field 0 होता है, लेकिन electric potential 0 नहीं होता है। क्यों नहीं होता बोलो तो देखो ये एक्सप्रेशन से E inside is equal to dV by dr. Since हमको पता है ये 0 है, according to Gauss theorem, जब ये 0 बोलो तो ये पूरा वैल्यू 0 होता है, ये पूरा वैल्यू 0 बोलो तो V क्या होना चाहिए? कांस्टेंट होना चाहिए। तो कांस्टेंट कितना होता है? जितना उसका सरफेस पर है वही वैल्यू अंदर भी होता है, तो ये पूरा वैल्यू कांस्टेंट होता है। गेटिंग व्हाट आई एम सेइंग? सो दैट वैल्यू इज दैट मच। सो ऑन द सरफेस, इनसाइड द सरफेस, सेम इलेक्ट्रिक पोटेंशियल। प्लीज टेक इट। Basing on this concept, I will give some some problems like you will solve. Okay, some concepts basing on this concept, some problem will see. It is helpful for you in any competitive examinations, or even it is in theory also. It's important. Let us see that also. What? Okay. Or shall I add this one? एक बार देखो पड़ेगा और एक बार आप लोग देख लो। Once again, you see, as I told you, if this is a spherical shell of charge, suppose say this is plus हो तो plus लेना, minus हो तो minus लेना, वो याद रखो, मैंने already बोला है। If suppose this is a ऐसा बोलो तो plus होता है, ठीक है? Suppose this is a plus charge, this is the R, then and this is suppose small r. At this point, what is the electric potential formula? V is equal to 1 by 4 pi epsilon naught into small q by small r लेना है। On the surface, q by capital R. Inside anywhere, q by capital R. Clear? Right. Now, basing on this, let us see one problem, one concept like. Suppose say this is one spherical surface given. This is one more spherical surface is given. There are two concentric spheres are there. There are two concentric spheres, means what? Common center they are having. Suppose say this is of radius A, this is of radius A, this is B. This is of radius A, this is of radius B. This is given. Say this is of charge Q, this is of charge, say this is capital Q. This is what I have given. Now, what is the electric potential on the surface? Say this is this on the surface of A. What is the potential on A? What is the potential on B? And what is the potential at center? Suppose this is O मैंने बोला. What is the O? यहाँ पर कितना है? यहाँ पर कितना है? यहाँ पर कितना है? ये अगर पूछे. So how to solve this? So first I am taking electric potential on this I am taking. Okay. तो यहाँ पर चार्ज Q है बेटा. सही है ना बेटा? मतलब ये कैसा है ये? This is nothing but on the surface. इसके लिए on the surface है ना? On the surface बोले तो 1 by 4 pi epsilon naught into this charge Q by ये distance कितना बड़ा? कहाँ चाहिए ये surface पर? By ये. Clear? यानी इसका पोटेंशियल ऑन द सरफेस हो गया, लेकिन बाहर भी एक और चार्ज है बेटा, उसका अंदर कांस्टेंट मैंने बोला था, तो उसका अंदर ये चार्ज इसका अंदर में है, तो इस पॉइंट पर ये सरफेस पर इसका भी पोटेंशियल होगा. इसका पोटेंशियल अंदर कितना है? प्लस 1 by 4 pi epsilon naught into ये चार्ज कैपिटल Q बाय क्या होगा बेटा? B inside. So इसका inside, so B. So total potential on this sphere is how much? With its potential plus its inside potential. Getting what I'm saying is, so in this way they may give two spheres, that is two concentric spheres or three concentric spheres or four, whatever may be. Similarly we have to follow. Clear? Now let us see for the B surface, that is the second one. ये surface पर कितना है? ये सरफेस पर कितना है? तो ये देखो बड़ा चार्ज इधर है, मतलब इसका पोटेंशियल बाहर है, इसका पोटेंशियल बाहर कितना पॉइंट पर, कितना डिस्टेंस पर? B डिस्टेंस. सो हम क्या बोलेंगे? 1 by 4 pi epsilon naught into its charge, that is Q, distance is B. This is whose potential? Its potential at that point outside, like इसका outside, plus its potential also there on the surface, that is on the surface for this. Therefore 1 by 4 pi epsilon naught into Q by B. Is it same? Huh? Both are same. No. Here Q by A, here Q by B. So there is a small changes there. So this one we have to see. समझ आया? What I'm saying is, अब आपको ऐसा देखकर व्हाट इज द डिफरेंस इन पोटेंशियल अगर पूछा तो हमको VB माइनस VA करना है. ये दोनों का डिफरेंस करें तो ये दोनों का पोटेंशियल डिफरेंस आ जाता है. गेटिंग व्हाट आई एम सेइंग इज क्लियर? गेटिंग? फाइन. नाउ व्हाट इज द पोटेंशियल एट दिस पॉइंट? व्हाट इज द पोटेंशियल एट दिस पॉइंट? ये पॉइंट पर कितना पोटेंशियल होगा? 1 by 4 pi epsilon naught into Q by B. बेटा ये पॉइंट इसका भी अंदर है प्लस इसका भी अंदर है, सो दोनों का सरफेस वाला ले लेंगे इनसाइड, बोले तो सेम ही वाला होगा बेटा. मतलब 1 by 4 pi epsilon naught into इसका चार्ज Q inside बोल रहा हूं, inside is nothing but same as that of the on the surface, that is ये इसका बोल रहा हूं, प्लस 1 by 4 pi epsilon naught into इसका भी अंदर है यानी Q by B. यानी what on the surface on the surface is same inside also. That's what we can see. Both are equal. सही है बेटा? मैंने आपको बताया ना, सरफेस पर जितना है अंदर भी सेम होगा, तो इसका सरफेस पर इतना था यानी उसका अंदर भी तो सेम होना चाहिए. That's what we are getting. So in this way we can solve any more also. Okay, so I will write one diagram like this. I will give you, solve it and show me next. Okay, next day you just show me. देखो ऐसा हम और एक ले दे रहे हैं. Say this is Q1, this is say Q2, this is say Q3. Here I am not telling any positive, negative. If positive is there, add positive. Negative means you can add negative. Okay. Generally, I am giving it as a Q1, Q2, Q3. Here Q1, Q2, Q3 may be positive, may be negative. Right? Say this is of R1. Say this is of R2. Say this is of R2. Now calculate the potential at V1, that is first surface. V2, that is on the second surface. V3, that is on the third surface. Okay, you calculate this and show me in the next class. Fine? Fine. Next. Take this one. Just to take this diagram. Shall I write this? Next is superposition principle of electric potential. Shall I write this one? Is that correct? Q1, Q2, Q3, R1, R2, R3. Very simple. Find out V1, V2, V3. Right. Now say here, superposition principle of electric potential. What is superposition principle? Already we have discussed the superposition principle in case of electrostatic force as well as in case of electrostatic electric field also. What is superposition principle means? Superposition principle मतलब होता है add हो जाना, मतलब at a particular point what is the total force. So the total force acting on any charge is nothing but it is the algebraic sum of the forces or individual forces acting on it via different charges. Suppose यहाँ एक charge मैंने दिया, इसके ऊपर कितना total charge हो रहा है, बोलते एक charge है, एक force act कर F1 plus और एक charge F2, F3, F4, F5. So total force on it is how much? With F1 plus F2 plus F3 plus F4 and so on. So this is called superposition principle. Means the algebraic sum of the total force acting on it due to this individual charges. This principle is called superposition principle. Similarly, here also superposition principle of electric potential means at any point how much potential is there or what is the total potential at a point due to n number of charges distributed. Suppose n number of charges are distributed, Q1, Q2, Q3, so on, they are distributed. At a particular point, how much potential is there? बोलो तो Q1 इनका distance suppose R1, तो इसका potential यहाँ क्या होगा? बोले V1 होगा. Q2 charge distance R2, इसका potential क्या होगा इधर? V2. और एक Q3 charge distance is R3, potential is V3, and so on. Qn distance Rn, potential is Vn. So यहाँ पर कितना potential है? Total potential V is equals to V1 plus V2 plus V3 plus V4 and so on up to Vn. So total, that means the sum of total potential at that point. Positive charge है तो positive लेना, negative charge है तो negative लेना. Keep in mind this one. So that's what. So let us say there are n number of charges are there of magnitude Q1, Q2, Q3. Let n number of charges, each of charge Q1, Q2, Q3, Q4 and so on up to Qn are distributed in a space which are at distances R1, R2, R3, and so on, Rn from the point from a point, say that is P. बोलो तो क्या है देखो. Say this is Q1, Q2, Q3, and so on like that. Qn are there. These are all at a distances R1. Suppose this is a point P. R1 distance, another charge R2, another R3, and so on like this. This is at a distance Rn. Okay, so at this point, what is the potential that we have to calculate? So therefore, the potential at that point is given by V is equals to V1 plus V2 plus V3 and so on plus Vn. What is given formula? 1 by 4 pi epsilon naught into Q by, first one is R1, Q1 by R1. Second one, 1 by 4 pi epsilon naught into Q2 by R2. 1 by 4 pi epsilon naught into Q3 by R3 and so on. 1 by 4 pi epsilon naught into Qn by Rn. Here 1 by 4 pi epsilon naught I can get common. 1 by 4 pi epsilon naught if I take common, what is left here? Q1 by R1, Q2 by R2, Q3 by R3 and so on plus Qn by Rn. There what I am saying is, so therefore this can be simply written as V is equals to 1 by 4 pi epsilon naught into Q1 by R1, Q2 by R2, Q3 by R3, etc. This I can write in the form of summation form. This can be written as summation of Qi by Ri. What is Qi and Ri? That is a general term where I is nothing but 1 to n. As we know that here I have taken a general term I, where I is nothing but 1, 2, 3 up to n. So I is run from 1 to n. So this is the general form. So this is the total potential at that point due to n number of charges. Suppose I have taken only 3 charges are there. So there I will take what? I is equals to 1, 2, 3. That means this can be written as Q1 by R1 plus Q2 by R2 plus Q3 by R3. How many you are taking? That much. Here, just take it. Okay, but thank you. Remaining topic we'll discuss in the next class. Okay, still then, bye. Okay.